Hello, today it is time to talk about 2.1 and 2.3 from our textbook. It's basically just continuing our discussion of conditional statements, logic. We do have a few new terms that I want to talk about. So go ahead and write 2.2/2.3 notes and then today's date at the top of your paper. You can see here that I've taken a picture of my notes, so I have them already done, but I will be talking about these a little bit at a time and using a marker so that way you know where I'm at on the page. You do not have to copy down the marks that I put on here during the video. Just copy the notes as you see them right now. All right? So today we're going to talk about perpendicular lines. I think a lot of you may already know about perpendicular lines. Perpendicular lines, of course, are lines that are perpendicular to each other. In other words, they meet at right angles. That is very important. We do have a symbol for that. So as you can see here in the picture, line L is perpendicular to line M, and so there is a symbol which I'm showing you over here in this area, the symbol for that, so that way you know how to write it. You will see me write perpendicular every once in a while, so you need to know that symbol right there. All right, so that's perpendicular lines. The next thing we're going to talk about is perpendicular to a plane. If you want, you can pause the video and go ahead and write that down, and then turn the video back on and we'll discuss it. And if not, we can just continue on. Perpendicular to a plane is a line that intersects the plane in a point and is perpendicular to that plane. So you see here I've drawn a picture of the plane, which is right here. And then I've got the line coming through that, hits the plane in a point, goes behind the plane, underneath it, where you can't see it, and that's why it's dotted, and then comes back out the bottom. So that right there is the perpendicular to a plane, line perpendicular to a plane. All right, next page, this just continues on our notes. Underneath that, you need to write biconditional statements. Biconditional statements are statements and their converse are both true. A biconditional statement is basically a combination. We kind of are lazy and we put together an original statement and its converse and we write them both together in the same sentence. So, for example, you have the original statement right here. If I study hard, then I get an A on the test. The converse of that statement, if I get an A on the test, then I studied hard. So basically switching the hypothesis and the conclusion. Now the biconditional of that statement is, we're going to combine those two statements, and this is how we do it. I studied hard if and only if I got an A on the test. So you can see that it looks really similar to the original statement. The only difference is we put this if and only if between it. All right, and the symbol for that is IFF. So whenever you see me this year write IFF, that means if and only if. And the reason we do that is because, let me go ahead and erase some of this so we can see it. The reason we do that is because we're lazy and we want to put the original and the converse together. They're both true, so it seems a little silly to write it in two different sentences when we can just write it in one. So the biconditional statement is I studied hard if and only if I got an A on the test. So that implies if I use this if and only if, then that implies that I got an A on the test, then I studied hard is also true. Now, you can only do that when the original statement and the converse are both true statements. If they're not both true statements, then you can't do that. That's pretty much all we have for notes today. I know that was short and sweet, but hopefully you got that all down, and we will see you in class soon.